Welcome to C.M.P lab. Today's video we are going to solve some problems on logarithm. But if you are not conversant with the rules of logarithm, you can check on our video on rule of logarithm. Okay, the first question says simplify log root 35 base 10 minus log root 7 base 10 plus log root 2 base 10. Now when you hear the word simplify in mathematics, it means make simpler or make smaller. You expect your results to be smaller. Okay, all right. So now we are asked to simplify the expression above. And this is why it's very important for us to know our laws or rules of logarithm. He said we should simplify this expression. But now, observe the operations, the arithmetic operations that are in between each of the term of this expression. We have a minus sign and we have a plus. Okay. Now, we have log root 35. We are going to consider this first. Log root 35 base 10 minus log root 7 base 10. Okay, all right. And the subtraction rule of logarithm says whenever you have two logs being subtracted, okay, what do? You take the logs to a single base and divide them. Okay, so this is what we are going to do here. Take these logs to single base and divide. So we have log 10 bracket root 35 all over root 7, okay, bracket close, plus root 2 plus log root 2 log plus log root 2 base 10. All right, plus log root 2 base 10. Okay, now we have applied the first rule here. Okay, now we are left with the second operation, which is the addition here. Okay, and the rule says whenever you have two logs being added together, you take the logs to single base and multiply them. Okay, so we are going to apply addition rule here. Okay, so have that log 10 bracket open 35 all over root 7 times root 2, okay, times root 2. All right, okay, so that we multiply this, okay, and if we multiply that, we have that root 35 times root 2 will give us root 70, give us root 70 all over root 7, okay, will give us root 70 all over root 7. And this expression can as well be written as log 10, okay, $70 all over 7. All right, and 7 cancels itself 1, and 7 goes into 70 10 times. All right, we have here 10 times. We have here 10 times, okay, so that we have that log 10, we have that this is equal to log root 10, okay, because we could open the bracket with an invisible 1 here, okay, so 1 times root 10, okay. All right, let's do this. Okay, we have that. Have this, so that if we open the bracket with an invisible 1 outside there, we have log 10 root 10. Okay, have log 10 root 10. Whenever you have a bracket and there is no number in front of the bracket, okay, you should just know that that bracket has an invisible one in front of it. Okay, all right. So here we have log root 10 base 10. Okay, so sorry, log root 10 base 10. So because we got from here 1 times root 10, so we have log root 10 base 10. Okay, so but from our rule of indices, we know that our roots, our square roots can be written as a half. Okay, that our square root can be written as a half. So meaning that root 10 can be written as 1 raised to the power of a half. Okay, so meaning that log root 10 base 10 can be written as log 10 raised to the power of a half to base 10. Okay, and we apply the product power rule here. Okay, and we have a half, okay, log 10 to base 10. Okay, and we know that log b from our rule of indices to base b is equal to 1. Any log, okay, to the same base, okay, any log that has the same number with its base, okay, is equal to 1. Okay, log to its own base is 1. All right, so that log 10 to base 10 is equal to 1. Okay, so that we have 1 times 1. Okay, all right, so if we put this in form of this one as a fraction, okay, we multiply 1 times 1 is equal to 1, and 2 times 1. 1 times 1 is equal to 1, and 2 times 1 is equal to 2. So we have that this is equal to 1 all over 2. Okay, we are going to solve the next question, which says find the value of x if log bracket open x minus 10 base 10 is equal to 1. All right, okay, now what this statement is saying, okay, is that at the end of the day, okay, at the end of the day, if we've determined the value of x, if we determine the value of x at the end of the day, we substitute it into this expression and simplify. We should have a result equal to 1. That is, at the end of the day, we should have a balanced equation. Okay, now all right, so but remember one thing, that from our rule of logarithm, that log b base b is equal to 1. Okay, all right, that is, I'm saying that 1 is the forward of log to its base. Okay, or is the proceeding of log to its base. Okay, so now what we are going to do, whenever it appears like this, what you do, okay, whenever it appears like this, what you do is you take a step backward. You take the expression, you take the 1 a step backward. Okay, now I'm saying that the 1 came from log to its own base. All right, so we'll take a step backward by writing 1 as log to its own base. Okay, and it cannot be to any other base than base 10. All right, so this is what I mean. Okay, I will write 1 log 10 base 10. We move a step backwards. Okay, log 10 base 10, 1 came from log 10 base 10. All right, so at this point we have log 10 on the both sides of the equation. So log 10 here will cancel log 10 here, so that we have that bracket x minus 10 is equal to 10. Okay, bracket x minus 10 bracket close is equal to 10. And then if we open our bracket with an invisible one, 1 times x, we have x. 1 times minus 10, we have minus 10. And this is equal to 10. And if we collect like terms, because we want to determine the value of x, so we have that s is equal to 10 plus 10, because the minus 10 crosses over the equality sign and the minus changes to plus. All right, and we have that x is equal to 10 plus 10, 20. Okay, but then let's check if the value of x we have here is actually correct. Okay, all right, now let's substitute 20 for x in this expression. Okay, let's substitute 20 for x. All right, we have check. Okay, so that say substitute, okay, 20 for x in the equation. Okay, so that we have when we have x, okay, in this equation, substituting it in this equation, so that when we have x, we put our 20 because our x is equal to 20. So we have log, okay, bracket 20 minus 10 is 10 equal to, all right, equal to 1. So that 20 minus 10 is 20 minus 10 is 10. So we have 10 base 10, okay, equal to 1. All right, so log to its own base is 1. Base 10 to base 10 is 1. So we have 1 equals to 1. Okay, so now you can see that our value of x is correct because we have obtained a balanced equation. All right, so the value of x is correct. Okay, we go to the next question, which says solve for x if log bracket open x minus 1 base 10 plus log bracket open x plus 1 base 10 is equal to log 1 base 10. Okay, so we have our solution. Okay, and we are going to apply the addition rule here. Okay, the addition rule of logarithm here. Okay, which says if you have two logs being added, okay, you take the, provided the bases are the same, you take it to the same log, okay, to base and multiply. All right, take it to a single base and multiply. All right, so we have log 10, okay, we use parentheses to differentiate the first enclosure from the second one. You have x minus 1 bracket close times, all right, times this, okay, x plus 1 bracket close parentheses equal to log 1 base 10. Okay, so from here we have log 10 on both sides of the equation. So log 10 will cancel log 10. All right, so that we have here that parentheses open, we have bracket x, okay, close, and we have, sorry, times x plus 1 equal to 1. Okay, so from here we'll multiply. Okay, we say x times x, and x times x is x squared. All right, you have x squared here. Now x times plus 1, we have plus x. Okay, and 1 times minus 1 times x, we have minus x. and minus 1 times plus 1, we have minus 1 equal to 1. All right, okay, and you can see here plus x minus x. Okay, we can simplify this. Plus x minus x. Okay, and plus x minus x is equal to 0. Okay, so this cancel this, and that's equal to 0. So you have x squared minus 1 equal to 1. Okay, so that we collect like terms. This one will minus 1 crosses over to the other side of the equation. We have x squared is equal to 1 plus 1. All right, it crosses over to here. So we have 1 plus 1. And x squared is equal to 1 plus 1 is equal to 2. All right, and we are not looking for the value of x squared, rather we are looking for the value of x. Okay, because we are looking for the value of x, we have to take the square off. Okay, and for us to take the square off, we take the square roots of both sides, because it is an equation. All right, take square root of both sides. Okay, to take the square off. Okay, we take square root of both sides, so that now we know that just like I said previously, like our square root in indices is a half. Okay, so if to take this off, x squared, you can write our square root as a half. So we have x squared bracket 1 all over 2, x squared bracket 1 all over 2, x squared. Okay, so that we have this with 2. Okay, and 2 times 1, we have 2 times 1, we have 2 all over 2. Okay, 2 times a half here. Okay, we have 2 all over 2, and this is equal to root 2. All right, so that 2 cancel 2 is 1. Okay, 2 cancel itself, 1 cancel to 1. 1 divided by 1 will be x raised to the power of 1. Okay, and any number raised to the power of 1 is still that same number. So x raised to the power of 1 is x. So we have x equal to root 2. Okay, the next thing we are going to do is to check the value of our x. Okay, if it's correct. But we had to take off this side of the board, the writing on the board, because we needed space. Okay, so we had that our x is equal to root 2. Okay, so we want to check the value of the value of x if it's correct. Okay, that is if we substitute root 2 in this equation, okay, we should obtain a balanced equation. If you substitute root 2 for x in this expression, in this equation, we should obtain a balanced equation. That's in the end of the day, what we have on the right hand side or on the left hand side should be equal to what we have on the right hand side. What we have on the both sides should be equal to each other. Okay, so that is what we are going to do here. So we'll substitute root 2 for x. All right, substitute root 2 for x in the expression there. So substitute root 2 for x in the equation. Okay, so when we have x, we'll put root 2. Okay, so we have log, all right, bracket root 2 minus 1 bracket close is 10 plus log plus log okay plus 10 bracket x plus 1. All right, bracket close. Sorry, we substitute x. Okay, we substitute root 2 for x, have root 2. Okay, substitute root 2 here for x. All right, so we have equal to log 1 plus 10. Okay, so we are done substituting root 2 for x in this expression, in this equation. All right, so the next thing we'll do is to apply the addition rule. Okay, so we'll take this to a single base and we multiply. So we have root 2. We use parentheses for the first enclosure. Okay, so we have root 2 close bracket times root 2 minus 1 bracket close times bracket root 2 plus 1, okay, bracket close. All right, close parenthesis. So we have equal to log 1 plus 10. All right, and so what next are we going to do here? You can see we have log 10 on the left hand side, we have log 10 on the right hand side. Log base 10, sorry, we have log base 10 on the left hand side and we have log base 10 on the right hand side. So log 10, log base 10 will cancel log base 10, so that we have that this is equal to, okay, times root 2 plus 1 bracket close parenthesis close. Okay, so that this is equal to 1 here. All right, okay, so we'll multiply this, so that we have root 2 times root 2. All right, root 2 times root 2 have 2. All right, anytime you multiply roots with identical number, okay, the root goes up, okay, and you have just the number. Okay, anytime you multiply two roots with identical number, okay, with identical number rather, you have the number. What I mean, if you multiply root 2 times root 2, you have 2. You multiply root 3 times root 3, you have root 3. Okay, all right, that's root b times root b will be equal to b. Okay, so root 2 times root 2 is 2, so that root 2 times 1 is equal to plus root 2. All right, and minus 1 times root 2, we have minus root 2. All right, and minus 1 times plus 1, we have minus 1. Okay, close parenthesis equal to 1. All right, so if we use what is outside the parenthesis to open, which is an invisible 1, we have 1 multiplied by all of this. Okay, and we should know we'll have this back. Okay, all right, so we have 1 times 2, we have 2 times this with plus root 2 times minus root 2 times minus 1 equal to 1. All right, so that you can see that this will cancel off. Okay, plus root 2 minus root 2 will have 0. Okay, so that's gone. So we have that 2 minus 1 is equal to 1. 2 minus 1 is equal to 1. Okay, so that 2 minus 1 is 1. Okay, equal to 1. What is on the left hand side of the equation is equal to what is on the right hand side of the equation. So our value of x is correct. All right, we are going to go to the next question, which says find the value of x if log bracket open x plus 5 bracket close plus log bracket open x minus 5 bracket close is equal to 4 log 2 plus 4 log 3. Okay, all right. Now if you look very well, you observe, you can see that there's no base on the logs, and this kind of logs we call them natural log, and natural logs are raised to or are in base 10. Rather, natural log is in base 10. Okay, so if you look at this expression very well, you see that the right hand side and the left hand side are not in the same form. Okay, in that on the left hand side you have numbers that are used to multiply with the logs. Okay, like we have here 4 log 2. Okay, all right, that's this is 4 log 2 means 4 times log 2. Okay, and 2 log 3 means 2 times log 3. Okay, they are numbers used in multiplying the logs. Okay, but now we have to put them in the same form with what is on the left hand side to continue so that we can proceed solving. Okay, that is what we are going to do next. Okay, so that we have log x plus 5, okay, all right, plus log, okay, bracket open, x minus 5 bracket close, all right, equal to, take this, okay, this came from product power group. Okay, all right, so we have log 2 raised to the power 4. Okay, all right, this came from this. Okay, all right, so we are taking this a step backwards. Okay, all right, so we have plus log 3 raised to the power of 2. Okay, 3 raised to the power of 2. All right, so if we apply the multiplication rule here, all right, but first before we apply the multiplication rule, all right, let's write here in a complete form as this, because it's not yet in complete form as this. It has power on top of it. All right, so we have log bracket x plus 5 bracket close plus log bracket open x minus 5 bracket close is equal to log 16 plus log 9. All right, so that if we apply the the addition rule here, sorry, if we apply the addition rule here, we'll have, notice now that they are now in the same form. Okay, we apply the multiplication rule here, we'll have log, okay, we multiply this x plus 5, all right, times x minus 5. Okay, this the dot here stands depicts a multiplication sign. Okay, all right, we took it to a common log to base, and we multiply. Okay, took it to a common base and we multiply. Okay, so that we have, this is equal to, we do same here, log, which we know these are all in log 10, base 10 rather, so we have bracket 16 times 9. Okay, so you can see that the log here, natural log here will cancel natural log here, and that's gone. So we have that bracket x plus 5 times, okay, x minus, all right, 5, which is equal to 16 times 9. So that x times x will give us x squared, and x times minus 5 will give us minus 5x, and plus 5 times x will give us plus 5x, and plus 5 times minus 5 will give us minus 25, and 16 times 2 will give us 144. All right, so we have here that minus 5x plus 5x, okay, we cancel each other because minus 5x plus 5x is equal to 0. Minus 5x plus 5x is equal to 0. So we have x squared minus 25, okay, equal to, all right, 144, okay, equal to 144. So we collect like terms from here. We have x squared, okay, we collect like terms, okay, minus 25 will cross over the equality sign, so that we have 144 plus 25 plus 25. So we will, okay, move to this part of the board, and we'll have that x squared, okay, 144 plus 25 is equal to 169, okay, yes. And to take off this the square, because we are looking for the root of x and not x squared, so we take the roots on both sides. All right, we have that x is equal to the root of 169 is 13. All right, and note we cannot say plus or minus 13, okay, we don't use plus or minus, okay, because when taking the roots, because this when taking the roots, because in logarithm the log of a number can never be negative, okay. Okay, the next thing we are going to do is to check the value of our x, but we have to take up the writing on the board so that we have some space, okay. So we are going to substitute. Remember, we said that our value of x was equal to 13, okay. All right, after simplifying, we had our value of x equal to 13, okay. So now we are going to substitute 13 in this we're going to substitute 13 for x in this equation, okay. So we have check substitute 13 for for x, okay, in the equation. All right, so okay, let's divide the board. All right, so all right, sorry, the statement, okay. So we substitute where we have x, where we have x we put 13. So this is x, so we put 13, 13 plus 5, okay, close. So we have plus log, okay, where we have x we put 13, have 13, okay, 13, okay, minus 5, all right, minus 5, this is equal to, okay, let's take this off, that we have equal to 4 log 2 plus 2 log 3. Okay, 2 log 3. All right. So we'll apply the addition rule here. Okay, so we'll take this to a single base, okay, and multiply. Okay, so have parentheses here. All right, parentheses, we have bracket log, all right, open 13 plus 5, okay, times bracket 13 minus 5 bracket close parenthesis, okay, equal to 4 log 2 plus 2 log 3. Okay, we are concentrating only on this side of the equation because we want to, at the end of the day, obtain a balanced equation that what is equal here. Okay, what we obtain on this side of the equation should be equal to what is on the right hand side. Okay, so that if we multiply this 13 times 13, okay, we've taken it to a single base, so we are multiplying now. That 13 times 13 was equal to, so we have log parenthesis, okay, 13 times 13 we have 169, and plus 5 times minus 5 we have minus 65. Okay, we have minus 65, and plus 5 times minus 13 we have plus 65. Okay, and plus 5 times minus 5 we have minus 25. Okay, so this is equal to 4 log 2 plus 2 log 3. All right, plus 2 log 3. Okay, if we simplify this, add parenthesis here, we simplify this, okay, we see that 65 minus 65 will go. All right, and we'll have log, we have log 169 minus 25, okay, which is equal to 4 log 2 plus 2 log 3. Okay, so that 169 minus 25 will have log 144. Okay, we have log 144. Okay, and this is equal to 4 log 2 plus 2 log 3. Okay, and if we take the prime factor, collect the prime factor of 144, because we want to write 144 in form of 4 log 2 plus 2 log 3. We want to write 144 in form of 4 log 2 plus 2 log 3. There's actually nothing we can do here again, okay, but we want to see how we can write 144 in this form. Okay, but if we collect the prime factors of 144 from here, we see that at 144, say 2 goes into 14, that is 7 times, goes into here 2, so we have that 2 goes into 144 72 times, and 2 goes into 72, okay, 36 times, and 2 will go into 36. How many times? 2 will go into 3 one time, remainder 1, and we'll go into 16, that is 8 times. We'll go into here, that is 18 times 2 goes into 36, 18 times 2 goes into 18 9 times, and 3 goes into 9, 3 times 3 goes into 3 1. Okay, so you can see here that if we obtain we multiply 2 times 2 4, 4 times 2 8, 8 times 2 16. The idea is that we want to write 144 in this same form. Okay, we want to write 144 as 4 log 2 plus 2 log 3. So that's the idea. That's why we are doing this. Okay, so if we multiply this, okay, 2 times 2, all right, 4, 4 times 2, 8, 8 times 2, and that will give us 16. Okay, we have 16 here, and 3 times 3, that will give us 9. So we can have 3 times 9, okay, from the prime factors here. Okay, but remember that 16 remember that in the rule of logarithm, that our multiplication is interfaces with our addition. Okay, that is to say that going forward, solving an added log, okay, two logs that are added, will be multiplying them, and going backwards, okay, going backward, two logs that are multiplied will be added. Okay, all right, so you know that from here, that here was 2 times 2 times 2 times 2 times 2 times 2 times 3 times 3. Okay, these are all the prime factors, and if you multiply this will give you 16, and this times this will give you 9. So I'm saying that if you writing 16 times 9, okay, all right, that this is in this form, writing it here in this form, that will have let's make some space here. Have okay, we have that 16, so 16 times 9. Okay, because of multiplication and addition and related, we take this a step backwards. So we have okay, you have log 16, okay, plus log 9. Okay, because if you multiply these two logs, log will have that this will be log, okay, 16 times 9. Okay, so we are taking this backwards, so we have this, all right, so that this is equal to 4 log 2 plus 2 log 3. All right, and if we write this in their index form, log 16 in its index form is log 2 raised to the power 4 plus log, writing 9 in its index form, that is 3 raised to the power of 3, right? Yes, 3 times 3, sorry, 3 raised to the power of 2. Okay, this is equal to 4 log 2 plus log 3. Okay, and if we apply the product power rule, okay, which says that if you have a log raised to a power, you use the power to multiply by the log. So here we multiply this, we have 4 log 2 plus 2 log 3 equals to 4 log 2 plus 2 log 3. Okay, so now from here you can see that what we have on the left hand is equal to what we have on the right hand. So the value of x was actually correct, which is 13. So we'll go to the next question, which says solve log bracket open 3x minus 15 bracket close to base 3 equal to 4. Okay, now if remember our definition of logarithm, that logarithm is the log of a number, say n, it is the power which is base will be raised to obtain n. That is the log of a number, say n. Okay, n to base a. Okay, all right. Okay, n to base a. It is the power which a will be raised to obtain n. That's to say, if you write this in exponential form, you have a raised to the power of x equal to n. All right. Yes. All right. So that if we write this based on the definition of logarithm, or based on or in its exponential form rather, we have we write it in its definition of logarithm, or in form of definition of logarithm, or its exponential form, we have this is solution what to, okay, this is the log here, this the 4 is actually the log here, so we raise the base to 4, and this is 3x minus 15. And 3 raised to the power 4 is 3 times 3, 3 times 3 times 3 times 3. Okay, so 3 times 3 times 3 times 3 is 81. And we have we use invisible one outside the bracket to open the expression in the bracket. So we have 1 times 3x is 3x, 1 times minus 15 is minus 15. Okay, all right. So we collect like terms here because we want to determine the value of x. So we must isolate, try to isolate x from every other thing. All right. So we'll do this. 81 minus plus, sorry, the plus will change to minus will change to plus because it expresses the equality sign. So we have plus 15 equal to 3x. Okay, so that 81 plus 15, we have that is 96 equal to 3x. Okay, and to determine the value of x, okay, so that x will become subject or will stand alone, we divide 3 by both sides. Okay, and 3 cancel itself 1, cancel 3 1, and 3 will cancel itself 1, 2 will go into 9 3 times, and 96 will go into 96 2 times. So that is 3 goes into 96, that's 32 times. All right, so we have that x is equal to 32. Okay, but we can check this, can check this we substitute we can check this if we substitute 32 for x in this expression. Okay, so we can check this. All right, so if we have check, so we have this. So if we write this log, have this expression log 3 log bracket 3x minus 15 plus 3 equal to 4. So that we substitute 32 for x. Okay, where we have x, we put 32, so we have 3, we use parentheses for the first enclosure, so that we have 32, okay, minus 15 parentheses close is equal to 4. All right, and 3 times 32, we have that log, we have that this is equal to parentheses open 96, okay, minus 3 times 32 is 96, plus minus 15 parentheses close equal to 4. Okay, we had base 3 here, sorry, base 3, okay, and we have that 96 minus 15 will be, 96 minus 15 will be, that's 81 half 8, okay, log 81 base 3, okay, equal to 4. All right, equal to 4. Okay, And if we write 81 in its exponential form, log 81 base 3 equal to 4 in its exponential form, we have 3 raised to the power 4 equal to 81. Okay, okay. So now if we write 81 in its index form, we have this is 3 raised to the power 4. Okay, we have that this is 3 raised to the power of 4, and 3 cancel 3. Okay, the bases cancel off. Okay, I will have that 4 is equal to 4. Okay, so now you can see that we have 4 now on this side of the equation. So we have 4 here. Okay, yeah. All right, have 4 here. Okay, it's equal to here. All right. Thank you for watching C.M.P Lab. Like, share, and subscribe to get notified each time we bring new videos.